All right, welcome to Chapter 6. In Chapter 5, we got the basics of integration and got some techniques, including U substitution. And there's more technique to come in Chapter 7, but in Chapter 6, we're taking a break to kind of look at some applications. So let me remind you, let me just give you a little recall here. Suppose you've got a graph, and suppose your function that you're graphing is like velocity for your car, and it goes faster for a while and slower for a while and faster again, and you're interested in maybe from here, from 1 hour to to there to 4 hours. And we know that if this curve represents velocity, then the total area underneath it is the total distance that the car has traveled, and we could work that out. But let's say that we're not just interested in one car. Let's say that we've actually got a second car, and this second car is just traveling let's say it's increasing its speed linearly. So the distance that the second car travels, of course, is also given by this area underneath its curve. But let's talk about how much further the first car has gone than the second car. Then we would be looking to figure out how far the second car has gone, and figure out how far the first car has gone, and the difference between them is this amount right here. And so we want to be able to say this yellow shaded area here now is the red car, minus how far the green car has gone, and it'll tell you how much further the red car has gone than the green car. So our focus in 6.1 is going to be to find the area between two curves. So let's go ahead and look at a just sort of algebraic example. So let's get a couple curves here. I've got x plus 4, and I've got x squared minus 2x. And you can see these curves do have an area in between them. It's already shaded. Unlike my previous example, I don't know exactly where I'm starting and where I'm ending. And that's one thing we'll need to figure out is say, where does this begin? And where does it end? It seems like from the curve, it's pretty clear that that's -1, -1 and 4. If that's not very clear from the graph, of course, you can figure out those points of intersection by setting the two curves equal to each other. So you could say x plus 4 equals x squared minus 2x, and I'm not going to do the algebra, but that's a quadratic equation. You set one side equal to 0 and use the quadratic formula or something, but eventually you'll work out those intersection points, which become our limits of integration. So when we talk about this area between the curves, so if you want the area between f of x and g of x in general, you would be talking about the area under f of x minus the area under g of x. And it's really as simple as that. Algebraically, we can manipulate this and just say that's a single integral of the two functions subtracted. And let's get the dx on there, and let's say we'll have limits of integration because we're looking for an actual area. So for our particular sort of red shaded area here that we want to find, we will be looking at the integral from -1 to 4 of the upper curve, which is the line. So that'll be x plus 4 minus the lower curve, which is the quadratic, and we do want to be careful to subtract the whole quadratic, so put parentheses x squared minus 2x, and close the parentheses and put a dx on the end. And in a way, that's the hard part, right? The integral is set up. We know how to do integrals at this point, theoretically. So we can just finish working this out. This will be -1 to 4. And we need to distribute the minus sign and collect like terms. So let's see, that's going to be a minus x squared. I've got x plus 2x, so 3x. So plus 3x plus 4. And again, I don't think the working out of this is really the interesting part here, but let's go ahead and finish it just for completeness sake. So to integrate that, you would get -1/3 x cubed plus 3/2 x squared plus 4x, and we'd be integrating that from -1 to 4. So plugging in 4, let's see, you get -1/3 4 cubed, which is 64, plus 3/2 4 squared, which is 16, and then plus 4 times 4, which is also 16, and then minus the same things with -1 plugged in. So that'd be -1/3 -1 cubed plus 3/2 times -1 squared plus 4 times -1. And I am going to stop there. I trust that you can crunch that number out, and I just made this example up, so I don't actually know what the numerical answer is. But like I said, I think you can finish it out from there. So I think that's good for our first example. In the next video, we'll look at a couple examples that are a little more complex.